Okay, in this lesson, we are going to talk about multiplying fractions. Okay, and these are algebraic fractions. And the rules that we learned for regular fractions back in fifth, sixth, and seventh grade apply to algebraic fractions. Okay, there's just a couple of extra steps thrown in. Okay, so the multiplication rule for fractions is to multiply fractions, you multiply their numerators and you multiply their denominators. So here's the numerators, here's the denominators, just like what we learned in our earlier math classes. So example 1, multiply 8/9 times 3/10. Remember to simplify before you multiply. If you had me in fifth and sixth grade, you know that I like really harp on this. Simplify before you multiply. In algebraic fractions, you have to. So I look and I say, well, 8 and 10 have a common factor of 2, so I can divide them both by 2. 9 and 3 have a common factor of 3, so I can divide those both by 3. And I'm left with 4 times 1, which is 4, and 3 times 5, which is 15. And so it's multiplied and it's already in simplest form. Okay? Here I have some fractions that have variables in them. I'm going to do it the same way. Here I have y squared and y cubed. They each have two y's in common. So these two y's, the y times y, will cancel out completely. This becomes a y to the first power. Okay. Here I have a 6 and a 15. Even though the 6 is being multiplied by 5, I can still simplify the 6. 6 and 15 have a common factor of 3. So that 6 becomes a 2. The x stays the same, and 15 divided by 3 is 5. So what I'm left with is 2x on the top, and here I have a y and a 5, so 5y on the bottom. Notice that it's already in simplest form. Okay, algebra. Example 3. Here's where it starts to get really fun. Okay, so in order to multiply these, I have to simplify first. And the way we simplify is we cancel out common factors, which tells me that I need to factor these first. So let's factor the first one. And I'm just going to make one big one because I'm multiplying all the factors are going to go on the top and the bottom. So this would be x, and that's going to be minus 4 and plus 3. Okay, and you can do x box. I'm just doing it in my head. X squared minus 25 is the difference of two squares, so I'll have x minus 5 and x plus 5. And I don't need to put the multiplication sign in between because the fact that they're in parentheses indicates they're being multiplied. Okay, here, this I can factor out a greatest common factor of x, and I'm left with x minus 5. And here I just have x plus 3. So now that they're completely factored, I can go through and cancel out common factors. So they have x plus 3 in common and an x minus 5 in common. So what I'm left with on the top is x minus 4 and x plus 5. And what I'm left with on the bottom is just x. So there it is. Okay, and we leave it factored. You don't have to multiply it back through again. So that's multiplying fractions, algebraic fractions. All right, now we're going to look at the rule of exponents for a power of a quotient. And basically what that means is if you have, and we talked about this before, if you have something in parentheses and an exponent on the outside, every single thing within the parentheses is raised to that exponent. So if I have a over b raised to the m power, that's the same as a to the m power over b to the m power. So let's look at this. If I have x over 3 to the third power, that's the same as if I had x over 3 times x over 3 times x over 3. Well, this would be x to the third power. This would be 3 to the third power, or 3 times 3 is 9 times 3 is 27. Okay, so everything within the parentheses gets raised to that third power. Let's look at our example 5. It says simplify. So here we've got two fractions we're multiplying. This one happens to be raised to the second power. What I can do then is I can simplify this first. Remember, because this is negative and it's being raised to the second power, it's going to become positive. So this will be c squared. 2 squared is 4. So this is what my problem looks like now. And it's important that you either write it this way or write it down and you show each step. So here then my 4's will cancel out and I'm left with just 1's. 1c will cancel out on the top and the bottom. So what I'm left with on the top is just c times 1, which is c. And on the bottom I have 1 times 3, which is 3. All right, so look at the try this. I'm going to go ahead and simplify this. I'm going to write it out sideways this time. B Here, 2a squared, remember everything in the parentheses has to be raised to that second power. So 2 to the second power is 4a squared times a squared over b. And notice how simplifying it first makes it easier then um, to um, to factor out, cancel out factors. So the b's will cancel out, and then I'm left with the ones there. The a squareds cancel out, and I'm left with 1 times 1, which is 1, and 4 times 1, which is 4. So my answer is 1/4. Here, I have one fraction, but it's being raised to the third power, which is the same as this fraction used as a factor 3 times. Because this negative and the exponent is odd, my answer is going to be negative, okay? Because a negative times a negative is a positive, positive times a negative is a negative again. 4 to the third power. 4 times 4 is 16 times 4 is 48. Let me double check. No, I'm lying to you. It's 64. And then n squared to the third power, you multiply the exponents, so it's going to be n to the 6th. So negative 64 over n to the 6th power.